Hello everyone, I'm Suraj Kesi. This is the artifact review 2 of Team 4 for the project row crop detection using computer vision and machine learning for steering of autonomous tractors. This video will cover sprint goals and overview, GitHub overview, working code demo on image processing, and research overview. This project includes Brandon, Kiran, Leo, Thomas, and myself, Suraj. Current sprint, which is sprint 2, which is started on November 6 and will last till November 19, 2018. That is day after tomorrow. The sprint goal for sprint 2 is to complete as much as we could do on image processing and do the research on ROS, OpenCV, TensorFlow, along with integration with the hardwares. For the sprint 2, we have created 8 user stories and various tasks. Most of have been completed and rest will be completed by the sprint is done. By the time this video is created, we are able to complete all the user stories that are related to the image processing, and the few remaining tasks, which are mostly on research parts, will continue do our research till the sprint is over. We'll use this research in our future sprint to implement the other project work. This is all on the sprint overview, and now I'll go ahead and hand over the another team member. Thank you.
I'm going to go over our private GitHub repo after nearing the end of Sprint 2 and show some of the changes we made to it as well as the new branches that have been created. For this sprint, we wanted to make sure that we had a clean Python script to work with, so we refactored and merged it into our development branch. We made sure to do a pull request and code review when we merged the branch with the clean Python script into the development branch, as you can see here from our pull request. We also went ahead and made our development branch our main branch for now, so all of the new branches created in Sprint 2 would be based off this branch. From there, each new branch followed the naming rules we set, where it would start with the user story number, followed by a brief description of basically what that user story is about, as you can see here. Now I'm going to go ahead and hand it off to another member of the team to show you the research that has gone into Sprint 2. Thank you.
Research efforts in Sprint 2 mainly focused on ROS, the robotic operating system, and drawing actual lines on the process crop row images. And we mainly focused on the hue transformation lines, and we actually applied that in our code and also made a wiki about it. For ROS, we went ahead and made a little dummy project. So let me get that started real quick. We're going to run the ROS core, which is the master node, sort of manages all the other nodes. And now we're going to run this little fun node called TurtleSim. Each time it gives you, well, it doesn't really matter what it does, but for each node we can actually go ahead and get information, so very important information. So the types of services it provides, what it's subscribed to, what other nodes it's subscribed to, where it's publicizing its information. So using ROS, we're going to be able to create multiple nodes that speak to each other and ultimately detect the crop rows and handle drawing the crop lines and then eventually passing that to the navigation system node.
Here's our current existing code. We are going to use it to process some images that we're going to use to train our neural network. The goal of it is to get the images of the crop rows and run them through some filters so that we can get the data and apply some Hoff transformations. That way we can get the lines where the crop rows actually are. Here is where we call all of that. This little section here is where it goes through all the processing. Right now we don't have the Hoff lines actually working yet, but we do have the grayscale, which converts the RGB image to grayscale, but highlights the original green areas. In the skeleton eyes, we're going to get an outline of the green plants, and then we're going to get a canny outline, and we're going to try and limit that to a relatively small area of the original image that we're actually going to be focused on. And let's go ahead and see that run. Here we can see several images of the outlines from the original images. And here let's show you the resulting files. Well, let's go ahead and look at the input first. We have various images that are run through the filter. And then our output, we can see that we see the general area where the plants are, and some skeleton with some lighter transformations on them. You can see the beginning of some Hoff transformations, but they're currently a work in progress and not fully functional yet.